Welcome to aminacademy.com. In physics, let us discuss about reflection and refraction of waves. First, we look at reflection of waves. If a wave collides with the wall, it also bounces back with some changes. If the wave collides with a rigid body, its phase changes. If the wave collides with a flexible boundary, it will be in the same phase. This is called reflection of waves. The Hertz transformation and the propagation of waves movement after seeking the phase of different two mediums can return reflected waves seen present after pursuing the change in the direction. The surface of the bouncing back wave. The significance of the reflection waves is to does not demand any plane surface for the reflection. Look at here, this is incident ray, this is a hard boundary and it's reflected ray with same angle with respect to the center axis. This incident ray is a reflected ray. Reflection of waves refers to the sensation where a wave can bounce back on the surface before returning to the source of direction. Sometimes it becomes difficult to comprehend due to the bouncing back nature of the waves. The reflective nature of the waves has two different mediums which are reliable. One is the object and another is the boundary of the mediums. Properties of the reflected waves. The reflection is possible to happen even on different types of rough surfaces such as walls, plywood and others. The spectacular reflection by motionless water is a great example of the reflection of waves. The angle of reflection to the stand is identical to the angle of incident to the benchmark. Reflection of sound. The reflection of sound waves law expression that the incident angle is permanently similar to the reflection angle. For instance, the sound waves can reflect by hitting the wall and they can recreate echoes of sounds. Reflection of light. The reflection of light wave has two characteristics. Either it is diffusive or mirror-like depending on the surface of the reflective part. The light reflective waves can occur whenever the light travels from one to another medium with a special ratio. The ratio determines the medium's optical density and the reflection of light. Here, this is some example for how the sound reaches our eardrum. Various types of waves. Different factors are connected with the distinct type of waves such as the direction and propagation and sometimes the type or depending on the law of motion. Hence, some of the waves types are as following. Electromagnetic waves. Waves that formed due to uniform and periodic perpendicular fields of electricity and magnets. The waves react normally on the plane surface. However, they behave like transverse waves. These waves can travel in both solid and both in medium and vacuum mediums. Light is an instance of electromagnetic waves in the physics. Now, about electromagnetic waves, we discuss detail in future videos. Longitudinal waves. Waves that produces the same medium and in the same principle as the incident waves to alternate the contraction are known as the longitudinal waves. The primary characteristics of this wave is it can travel in different types of mediums such as liquid and solid as well. Transverse waves. Waves that follows the perpendicular direction during the propagation and the direction in managing the incident waves or the transverse waves. These waves can travel only through the solid medium. Fixed end reflection. In the situation where the string can get fixed with the walls and the right end at it allows to propagate via other strings to construct the vibration reach the right end can reflect again. The moment when the vibration arrives at the wall to construct the appeal of force, it follows the third law of Newton's where the reaction is equal to the action. Free end reflection. In a situation when the right end of a string is tied to a strong, which is up front and down without any disagreement of on a rod, it is termed the free end of reflection. In this case, when the vibration arrives at the right end, the ring drags up the rod and as it shifts. Look at here, this fixed end like a wall or pole. The rope is tied here and it's called a free end. It's an incident pulse. Here, look at here. Then it's written reflecting waves written here. The vibration goes like and return back here. Then reflected pulse like it happened. Now next we'll discuss about refraction of waves. A refracted wave is a wave like light that has changed the direction bent by moving from one material to another material of different densities. Look at here, incident ray passes through, suppose it's through air and further it passes through a glass medium, different medium, so it's bend its direction. So it's called refraction of light. A refracted wave is a wave like light that has changed direction bent by moving from one material to another material of different density. If the new material is denser, it will refract towards the normal. If the new material is less dense, it will refract away from the normal. The timber is often described in subject terms, for example, reedy or golden. Now we'll discuss about further something superposition of waves. Look at this figure, three waves, sinusoidal waves, two waves meet at one point, two or more waves meet at one point. Here, this point and this point is a superposition. According to the principle of superposition, the resultant displacement of a number of waves in a medium at a particular point is the vector sum of the individual displacement produced by each of the waves at the point. At the point here, this displacement is vector sum of that each wave. So far we discussed about reflection and refraction of waves and superposition and different types of waves shortly. We have done. Please subscribe our YouTube channel.